Today we're looking at dividing polynomials by monomials. So up until now we've done a lot of multiplying polynomials together, polynomials with monomials, polynomials with polynomials. Now we're doing the opposite, the inverse operation. So first we're going to look at dividing by just a number, a constant. So the first thing, remembering back to algebra tiles, just asking you here to state the expression to show how many algebra tiles there are there. So that's 4x plus 8. Okay. Really, that's the area of that entire rectangle. So then it says divide the above expression by 4. So show the division statement and the quotient answer. So think about this shape here. If we have to divide this into 4, it means each part has to be exactly the same. So it kind of makes sense that we're dividing that part and this part, this and this, because each one of those circles has the exact same tiles in it. So when we divide by 4, so divide the above expression by 4, show the division statement. So I'm going to go 4x plus 8. You can either show it with a divide symbol or in a fraction, dividing by 4. And so what we get is whatever's in one of those circles. So that's x, there's one x and two ones. Okay, so look at what happens here. As I've got the method written out, every coefficient and constant term in the polynomial needs to be divided by the constant divisor. So 4 divided by 4 is 1. We don't have to show the 1. And then 8 divided by 4 is 2. Okay, so you just have to treat every term equally. Just like when you were distributing by a constant. Every term got multiplied by the number. Now every term gets divided by it. So here, first one is just a monomial, right? So really, we've done this back in the powers unit. You're just dividing the coefficients here. So that's going to be 27x squared. This one, we're dividing both terms. It's a binomial divided by 2. So 2 divided by 2 is 1. So that'll be 1x, which we just show as x. 8 divided by 2 is 4. And it's a plus in between. Okay, that's a positive 8. How do you check your answer? You go and take your divisor 2, multiply it by your quotient, and you should get your original. Okay, this is actually called, this is called the dividend. Ooh, can't write very well with my mouse. Dividend. This is the divisor. And this is the quotient. Sorry, quotient. There we go. All right, so next one. It's a trinomial divided by -6. If we don't like to leave a negative in the denominator, so no matter what, we want to divide by -1. But here, check, does 6 go into everything? And it does. So really we can divide every term by -6. So we get -2x squared minus 3x plus 5. A negative divided by a negative is a positive, and a positive divided by a negative is a negative. And then here, same thing, trinomial divided by -2, so every term gets divided by -2. So that's just going to be 1x squared plus 6x minus 4. Okay. Then polynomial divided by a monomial. So state the polynomial represented by the tiles that form the rectangle. Okay, so we want basically this is like the answer in a multiplication, and then we're going to work backwards. So there's 2x squareds. Okay, and there's 6x's. Then it says fill in the guiding tiles that form this rectangle and show the division statement. Okay, so here the guiding tiles, I'm just going to do it in black here, that, and then we'd actually, because this is the side length, is just 1 unit for each of these. So I apologize for my non-squares, but I'm just using my mouse right now. That would be our quotient. So when we're taking 2x squared plus 6x and dividing by whatever's on the left here is 2x, okay, we're going to end up with what's up here. This should be colored. Sorry, I should color that in. So that's going to end up being 1x plus 3. Okay, so same as when we were dividing by a constant, now every term gets divided by the denominator. So 2 divided by 2 is 1, x squared divided by x is x. Positive 6 divided by 3 is 3, x divided by x, they go away. Okay, so this is your quotient. So it really works with, remember, dividing is the opposite of multiplying. So here's the method. Every term in the polynomial needs to be divided by the monomial divisor. That means that every coefficient and constant will be divided by the coefficient of the denominator, and power laws will be used to divide the variables in each term. So let's practice. Again here, it's a monomial, so that's going to be negative 6 divided by 2 is negative 3, and x squared divided by x squared is 1, so it's just negative 3. Here, we'll leave the negative out front. There's just one negative. 16 divided by 8 is 2. X's divide out totally, and y to the 6th divided by y to the 4th is y squared. Now, each term by 3x. So 12 divided by 3 is 4. X squared divided by x is x. So that's going to be 4x. Positive divided by positive, so that's going to be plus. And the x's divide out. 9 divided by 3 is 3. D, again, a binomial. So 15 x cubed divided by 2x squared. It's not going to go in evenly. So we're going to show it as 15 over 2 x squared. And then negative 6x divided by 2x is negative 3. So we're going to go show it as a subtract 3. Okay, now a trinomial. And we're divided by a negative. So a negative divided by negative is a positive, and they're 3s. So going to be left with 1. X to the 4th divided by x squared is x squared. Then negative 9 divided by negative 3 is positive 3. X cubed divided by x squared is x. 12x squared divided by negative 3x squared is negative 4. So change that to subtract 4. And how can you check? Multiply your answer by your divisor. Okay, then here 14 divided by 7 is 2. The n's divide out, but there's nothing to divide out the m. And then 21 divided by 7 is 3, and it's minus. Okay, and n squared divided by n is n. You just have to treat every term the same, just like you did when you were multiplying. Okay, so next thing, to help us really with tomorrow's lesson, we want to think about prime numbers and prime factoring numbers. So if a number has a factor, then the factor divides the number evenly without a remainder. So list all the possible natural number factors of 30. So we know that 1, so we want all the possible factors, and then we want to take a look at the prime factors. So 1 times 30 gives you 30, or we could have 2 times 15, or we could have 3 times 10. 4 doesn't go in, or we could have 5 times 6. So those are just pairs of factors. I didn't really actually say pairs, so you may have started to do prime factorization. In any case, a prime number is a number that is only divisible by 1 and itself. So is 30 a prime number? No, because we found all of these, right? Is 1 a prime number? Actually, no. So a lot of times students think it is, but if you think about it, in this definition here, it's only divisible by 1 and itself, and these two have to be different numbers, and that's what we don't say in there. So this is divisible by 1, but itself is 1. So those aren't two different numbers. Okay, so which of the factors of 30 are prime factors? So 2 and 3 and 5. Okay, so 2 and 3 and 5. All the other numbers, that's one's not considered prime, and the other ones are, we call them composite numbers. List the first 10 prime numbers. So remember, 1 is not 1, but 2 is. Okay, and 3 is, and 5 is. So these ones here that we just listed are all prime. And 7. So the thing to remember for prime numbers, the smallest one is 2, and 2 is the only even prime number ever, because any even number is divisible by 2, but when you get down to 2, it's 1 times 2, and so it's prime. So not all odd numbers are prime, but many of them, there's an infinite number that are. So if you just start counting 3, 5, 7, 9, well, you know 9 is 3 times 3, so that isn't going to work. 11, 13, 15 is not prime, 17, 19, 21 is not prime, that's 3 times 7, 23, so where are we at now? 3, 6, 9, so one more. 25 is not prime, 27 is not prime, and 29. Okay, so that's the first 10. The prime factorization of a number is the number written as a product of all its prime factors. So that's not what we did up here, right? We just found possible factors of 30. Sometimes you might want to consider a prime factorization. This is what prime factorization is for 30, right? 2 times 3 times 5 equals 30. And those are all prime numbers. So if you get to bigger numbers, you may have learned this in junior high, you split it up and kind of put branches on your tree. And I always start with the smallest prime number. Does 2 go into 60? And it does. And so I show it is the two factors that multiply to 60. And then I keep going until I get only prime numbers at the end of each branch. So 30 is not prime. But we just learned that 30 was 2 times 3 times 5. If you weren't sure, then my tree, I just do it in pairs of arms or branches. 30, I would then go 2 again. So 2 times 15. And then 2 is a prime, so that branch is done, and 15 is 3 times 5. So now if you look at each number at the end of each branch, those are your prime factors. Sorry, just a sec. Okay, so could we have started with another set of factors of 60? Yeah, for sure. You could have started with 10 times 6 and then done your tree. In any case, I'm just going to write out the multiplication here. I'm just using a dot in between to mean multiplying. Make it a little bit bigger. Okay, and that's equal to 60. Okay, so yes, we could have done that. All right, so then that helps us in coming up with the greatest common factor between two numbers. So write all the factors of 60. So I just did 2, 2, 3, and 5. So they multiply to 60. Okay, now for 24, so if I did a tree here, then I go, okay, 2 and 12, and you can use your calculator. Just keep working back. 12 is 2 and 6 multiplied together, and 6 is 2 times 3. Okay, so all the factors of 24 are 2 times 2 times 2 times 3. Okay, so that's 24. Now, if you wanted to use powers, you could go, okay, that's 2 cubed times 3. Over here, you could say, okay, that's 2 squared times 3 times 5. Okay, so greatest common factor that is common to both. So you want to look at, here I should probably, I'll circle the prime factors here. So you want to find all the factors that are common. So here, this 2 is common with this one. Okay, this 2 matches with this one. Now I need a 3 and a 3. There's no 5 over here, and there's no extra 2 up here. So you've got to match them up within each. So 2 times 2 times 3. Okay, so what is 2 times 2 times 3? Let me just fix this here. So 2 times 2 times 3 is 12. So 12 is the greatest common factor of both 24 and 60. It's the biggest number that divides into both of those. So that's a way of figuring it out. Okay, you don't have to prime factorize. You could look for all the possible factors that multiply to 24 and what's common. Okay, but this guarantees it. So the greatest common factor of 2 or more numbers is the largest factor that is common to all of the numbers. Okay. So, greatest common factor of 60 and 90. So you can prime factorize it. Now what you might want to do you have to do all of that? Like if I see a 60, it has a 0, 90 has a 0. So I know this is 6 times 10, and 90 I know is 9 times 10. So for sure, I don't have to prime factorize 10 because I know it's common already. All right, so now this is common to this, but I haven't prime factorized the other. So here, 6 is 2 times 3, and 9 is 3 times 3. So now what's common there is this 3. So the greatest common factor, and we often abbreviate that to GCF, is 30. So next one, 200, and again, same thing, is I see a 0 at the end, right? So maybe I'm going to go 20 times 10, because 630, I see 0 at the end too. So that's 63 times 10. And so for sure 10, I don't have to prime factorize that. I know 10 is common. Now between 20 and 63, is there anything common there? So then you can go, okay, well that's 4 times 5. And this is what? 9 times 7. Okay, and then from there, 4 is 2 times 2, and 9 is 3 times 3. So there's nothing more that's common. So 10 is the largest, the greatest common factor. All right, and so that's going to help us with common factoring, so that we're starting that today, and then we'll do some more tomorrow. So find the greatest monomial factor that is common to all terms, and divide each term by this. Express the answer as a product. Okay, so when you're asked a common factor, you're looking for the GCF of every term, and then you're showing it as a product. So really you're doing a dividing and then showing it as sort of a check in a way when you multiply back. So looking at 6, 9, and 12, biggest number that goes into all of them is 3. Take a look at the variables. Is there an x in all of them? No. So we can't divide by x. So it's going to be 3. And so I'm just going to do it in a different color here. This is my work. Is dividing every term by 3 like we practiced before. So now what do I get? Well, 6 divided by 3 is 2. X squared stays. 9 divided by 3 is 3. And the x stays. And negative 12 divided by 3 is negative 4. So subtract 4. And so then if you expand this out, you'll get back to your original. Okay? But the greatest common factor goes out front. Greatest common factor. Okay? So the next one, 24, 30, and 6. Well, check. Always look at the smallest number. Does it go into the other ones? And it does. So 6 is going to be your greatest common factor because there's not m's in all of them. So now 24 divided by 6, I'll show my work here. So really what we're doing is dividing by 6. And you're going to get 4m to the 4th minus 5m cubed. And 6 divided by 6 is 1. Okay, and then you can expand back to check. Next one, 15, 20, and 10. Well, anytime you have zeros or 5s at the end, you know 5 is common. 10 is the smallest, but it doesn't go into 15. So 5. Take a look here. There's x cubed, x squared, and x. So also x is common. So we're going to divide everything by 5x. So 15x squared cubed divided by 5x squared. 15 divided by 5 is 3. X cubed divided by x is x squared. Then plus 20 divided by 5 is 4. X squared divided by x is x. And then minus 10 divided by 5 is 2, and the x's divide out. You know that you've found the greatest common factor if you look at your brackets and then there's nothing more that you can divide into the coefficients, and there's not the same variable in all the terms. All right, last one. This one's a bit tougher. So 14, 8, and 6. They're all even numbers. So 2 for sure. Check 6. Does 6 go into all of them? No, it doesn't go into 14. So 2 is the number. Then there's m's in all of them. So you've got m squared, you've got m, and m cubed. Only 1 is common to all of them. So you want to basically look at the lowest exponent on m. Then the lowest exponent on n is n squared. So there's 2 here, 4 here, and 3 here. So for sure there's 2 in all of them. And then that's what you're going to divide everything by. That's your greatest common factor. Okay, and so 14 divided by 2 is 7. M squared divided by m is m. N cubed divided by n squared is n. So you're just using your power laws. Then the next 18 divided by 2 is 9. M's divide out. N to the 4th divided by n squared is n squared. Then minus 6 divided by 2 is minus 3. M cubed divided by m is m squared. N squared divided by n squared, they divide out. Okay, nothing common to all, and they are probably here. I'd probably rearrange it. I've always talked about alphabetical order, but for today, I'm just going to leave it. Okay, and that's it.